Yo, what's going on in this?
Hello. Yeah, I can hear you. Um, well, I'm starting on the implementation for those extensions that I want to do. And it's getting complicated, so because I need a lot of like really weird data structures. Um, well, okay, so one is I just need a bit mask. It's not that weird, except C# doesn't have one. Um, like, I mean, you can use yeah, you can use, you know, like just an integer as a bit mask, that's fine. But I need a dynamically sized one, right? Because I need 1 bit for every component in the game, right? So I was implementing that, and that wasn't so bad. But here's the thing. Okay, so basically, what I've got is you create a bit mask for components specifically, okay? And because you can create components during runtime, the size of the bit mask can change basically at any point in time. Okay? Which means I can't just allocate it and then leave it, right? Because you know, you create a bit mask, then you add some components, and now that bit mask is useless, right? So what I'm doing is I'm actually storing all of the bit masks for the components specifically in one centralized location, one big array. And then I'm basically just delegating, you know, the first 50 bits for the first mask and so on and so forth. And then when I create a new component, I just shift them all to where they need to be for the new, based on the new set of components, right? That way if I add one, then I've effectively added 1 bit to every single bit mask that currently exists. And I've updated them to make sure that they're all still what they were before, right? Like they still represent the same components that they did before. Needless to say, a collection like that does not exist, right? That is so absurdly specialized. So that's what I was working on figuring out. Well, yeah, I know how to do it. Like the thing is, it's not that it's difficult to implement. It's just that it has to be implemented. And I could look at the C library, sure, but I can't just call C code from C sharp, right? So I still have to implement a carbon copy if I wanted to. Yeah. But whatever. It's basically done now. And while I was at it, I decided to build a bunch of utilities for just twiddling bits around. You need bitmasks for a bunch of other stuff too. Like change detection for components, right? That's going to be represented as a bitmask. What entities got destroyed or created in this frame, that's also a bitmask. So on and so forth. And then one other thing that's really a bit frustrating. C sharp, all of its collections, they all exist in managed memory. Which means if you're doing a lot of work with unmanaged memory, which I am, that's how I'm storing the components, then you basically can't use the collections. There's like 2 that you can use. You can use span, which just represents like a contiguous block of memory, right? And memory, which represents the exact same thing, except it might be unmanaged or it might be managed. Like, yeah, it's basically the same, right? So that's the other thing I was doing today is basically designing unmanaged versions of all the standard collections. And I don't know, it's done. So, and mine have one advantage: you can pass it an allocator. Because well, there's like 1,000,001 cases where I need to represent like, you know, a stack or a list or whatever. But it's a small one, and I could just throw it in on the stack with Does Java have a stack alloc keyword or anything like that? Where you basically it allocates memory directly on the stack. Yeah, it's so useful for optimizations with small collections. So my collections are designed so that you can either back them with memory off the heap, or with memory from the stack using stack alloc keyword. Or like any other, you know, allocator that you design. Because there's actually one that I actually really want. Scratch allocator for the frame. Right, because during a frame there's a bunch of stuff you need to allocate, and it's only going to live for that frame. Right? Whoop, that's under me. So, oof. So I made a scratch allocator that's just going to get cleared at the end of every frame. Right? That should reduce garbage collection to nearly 0. Yeah. And like keep access also to nearly 0. Because pretty much everything will end up getting allocated either in the entity system, which is keep access, but it's optimized so that it minimizes the amount of times it has to, you know, allocate and free stuff. Or it's going to be thrown on the scratch allocator for that frame. Yeah. But are they managed collections, or are they unmanaged? Both. Okay. Because C# only has managed collections. Doesn't have anything for unmanaged. Oh. No, it isn't. Yeah. Well, the thing is, I can look at C#'s managed collections actually, because the thing is, it's just like colored types, basically, right? So the implementation for managed versus unmanaged really is pretty much the same. It's just instead of using a managed array, I use a pointer and a number to keep the length, right? That sort of stuff. So I am using their collections for reference to make sure I implement it all correctly, but yeah. Yeah, but I'll tell you what, the more I'm doing this stuff, the more I'm realizing C++ is so much nicer in some ways, and I still can't use it, which sucks, but because well, I need to be able to load code at runtime across many platforms for mods, and C++ just doesn't do that very well. I'm sure it's possible, but with C# it's IL, right? So it can get you optimized and converted for whatever CPU architecture you're running really. Which means you can just distribute one file for the mods. But if I wasn't doing that, I probably would have done this project in C++. Because it has all these things, right? And it doesn't have managed versus unmanaged, and it doesn't have garbage collection. Because that's the thing I'm like desperately working to avoid it. Because it's so tough stuff. Oh, nice. Yeah. Hmm? Mm-hmm. Yeah. Mm-hmm. I don't even know what I was saying. Right, yeah. So like the managed stuff is just so annoying to work with sometimes. Well, more specifically, it's annoying because it's slower than unmanaged. Um, and C# doesn't have a lot of support for working with unmanaged memory. Like it has all the low-level stuff, all the low-level operations that you'd need, but they haven't built much on top of that. Like collections, right? So I have to build it all. It's fine though. Ah, that's that's fast. Mm-hmm. Yeah. Yep. Oh yeah. I mean, I could do it with managed memory. Um, the reason I'm not is simply because I'd rather have more control over it, for one, and the other one is actually I do have some concerns that I'm going to be allocating, you know, hundreds or thousands of tiny little objects every frame. Um, and if I'm trying to, well, if I'm trying to do some of the games that I've planned out, like it will not be enough. Um, yeah. But I'll tell you what, there's one super nice thing about C#. It's so nice. It's got this standardized SIMD set. Okay. The type is called vector, and It's a generic type, so you got, vector of byte, vector of int, vector of whatever. And as long as it's one of the primitive types, then it will try to use SIMD instructions on them. So the vector is 128 bits, always, no matter what type arguments you're using, right? And it will just convert the addition operations, for example, to SIMD variations of them, if the current computer that you're running supports them for that size. You can even do vector 512, and what that will do is it will use AVX2-512 instructions if your computer supports them, and if it doesn't, then it will fall back to other instruction sets. Basically, it will use AVX2 with 256-bit registers. We'll use 2 of those. Or if your computer still doesn't support it, it will fall back to like all the way down to just 64-bit or 32-bit instructions. Which means I can get SIMD without having to recompile for different platforms, and without having to do a bunch of weird runtime linking bullshit, because the JIT compiler will just handle it. As long as I use those types. Well, so, I mean the IL version of JIT, not Java's JIT. This is C# version of it. Okay, yeah. Right, C# has something like that. Yeah, C# has something like that. So when you're compiling to intermediate language, which is basically a bytecode, right? Then there's a bunch of flags you can set. One of them is you can compile for size, and the other one is you can compile for minimizing instructions, and the third one is compile for speed. Okay, but then also the jitter also has the same options, and it will use those to do optimizations when it converts the intermediate language into assembly, or rather native, right? But and I have actually disassembled a bunch of testing functions just to see what it will optimize it into SIMD and stuff. The jitter's not very good at it. You really do have to use the types, otherwise it just gets confused and it doesn't generate SIMD very often. Like I made a vector type, right, which just has X, Y, Z, and W. So the size is 128 bits, and they're in the right layout for you to use. I can't remember if it's AVX or SSE2, but one of them. And the jitter for C#, it won't turn that into vectorized instruction. I even like manually overaligned it to 128 bits or 64 bits. No, 128. Yeah, that's the alignment that I wrote. And it still wouldn't. So I'm using C# because they provide a guarantee that it will always convert into vectorized if it can. Yeah. And obviously they're unmanaged types, right? They're just a set of 256 bits. Oof. That's nice. Rock in the middle. I'm back. Oh, we're good. Ah, I hit the roof. I did not mean that to happen. I'll take it. And you know what though? The bit sets the bit collections I was working on, they they work a hell of a lot faster than the standard one that comes with C# because they do have a bit array structure. I don't know what they did to it though, because it doesn't run that great. It's either because they aren't using SIMD for the comparisons, or they might even be doing like 1 byte per bit. You know what I mean? So it just eats memory. I don't know. The standard C's bit array implementation. I'm gonna check the CS because you can access the source file. But I was doing performance comparisons between theirs and mine, and mine's like 200 times faster. It's like, what the fuck? I can't be doing this right? It's gotta be just that they aren't using SIMD for the comparisons now. Because my computer, it does have AVX, not 512, but it has AVX2 at least. Right, so it's capable of doing 256-bit comparisons per app. Yeah. And then I guess if you pad mine, they might not pad theirs. Because my bit array, it's set up so it pads it with, so it's always a multiple of 256 bits. And then if the last ones aren't included in the array, then you don't get access to them. But it will still compute them. Because it's faster to do it that way, right? Because that way I don't have to deal with, oh, what if the array isn't a multiple of 512? Here we go. I don't know. Here we go. What? You know what it could be? Branching. Because I'll bet you they still do bounce checks for their collections. I mean, I do it if you have a flag enabled. When you compile, right? But if you disable the flag, if it's not in debug mode, then I just strip out all the bounce checking. No, that's terrible and dangerous, right? But it will throw exceptions when you're debug mode, at least. There we go. Because it could also be that. It could be that it's doing bounce checking for every, presumably 8 or 64 bits that they access. And then the branch kills it. Oh, that's in. Yeah. There could be a lot of things. Thanks, very nice. This is C sharp, not C. Right? Yeah. No, I don't trust him. Hence my own collections. Yeah. Because I actually did implement one of C sharp's collections a while ago, pretty much line for what they did. It was a hash set. But I did it so that it would use unmanaged memory, right? And just converting into unmanaged memory gave me like a 20% improvement in performance. And then, I know. And then I did, some stuff with the hash function, and I was able to like double it again. And then, so the way they implemented it, I think, this was like over a year ago though, so I might be misremembering. They store the keys, right? Or sorry, the hashes. They store the hashes in a sister array. Because that way they don't have to recompute them all the time, right? And I mean that's smart to do if you can afford it with the memory, right? If you've got a complicated hash. But what I did with my implementation is I ended up just merging them into the same collection. It makes iteration like very slightly slower because you end up loading the hashes into memory too, right? But it makes insertion and deletion stuff much faster because the hashes are right next to the elements. They're in the same array. So instead of accessing two completely different places of memory, because that's the thing, they allocated them separately. Not just like different sections of the array, but completely separate allocations. And that gave me another like 50% improvement. So, there's a lot of space for improvement with C-Sharp's collections. There we go. I got it. There we go. Just boost, I didn't know if he did, so. Got him. Mhm. Yeah. Mhm. Oh, oh, that's fast. I got it. Uh, yeah, I'll head back 'cause he's got it. That's oh, nice. I got it. There we go. I finally, I realized one of the biggest things that probably slows down the collection. Because, like, 20% for just converting to unmanaged seems high. Right? I think I figured out what it was, though. I set it up so that my comparison functions, it just stores the vtable directly for the compare function. It just stores a pointer to the function. That's it. Um, it's slightly more limited, right? Because it means that the comparison can't hold state. But how often do you need it to anyway? Um, whereas in the standard implementations for all the collections, they store a member called compare, and it's an object that has a function that implements an interface to compare two elements. So that means is it has to go to the objects allocation, pull its type information, and then look up the vtable that's stored in another location, and then call it. That's why it's slower. Right, because whereas I just have the vtable directly there. Because it's a small vtable, it's one function, right? Like, uh, there's something. Sure, okay, so, well, in normal managed code, right? You got your class, and then you've got, when you create an instance of an object that has virtual methods in it, then the actual allocation is going to store a little integer with it that tells you what type of object is allocated there. And then what you do is you take that integer, you use it to index into an array of function pointers, and that's your vtable, to figure out which implementation of that function should actually be called. Right? Because you'll have like, for example, well, let's just go with shapes, right? There's going to be a function to, I don't know, get the perimeter. And there's going to be two different ones for squares and circles. The implementation is different. And they're both going to actually take the exact same arguments, weirdly enough. They're going to take a pointer to this, which technically the pointers are different types, but they're just pointers, so you can interpret them however you want, right? And then, I guess perimeter doesn't actually take any other arguments besides that, right? But it's going to take a pointer to the shape. If you have two classes that implement shape, and one of them is square and one of them is triangle, well, three, and the third one is circle, then you're going to have a v-table with 3 entries in it. One of those function pointers is going to point to the function that should be called for getting the perimeter of a circle. And the other one's going to be pointing to the function that gets the perimeter of a square, and the last one's going to be getting the perimeter of a triangle, right? And then when you create an actual shape, a triangle, then it's going to allocate the memory needed to store the triangle, but it's also going to allocate an extra few bytes to store the type ID, right, to identify that this is in fact a triangle. Because otherwise there's no way to know if this is a triangle or a circle in terms of memory, right? Because it's just a bunch of bits. And then you use that integer to index into the v-table. Yeah. Yep. And like Java and C# and every other language, including C++, they'll do this automatically for you. There's going to be a global hidden chunk of memory that has all the v-tables and all the type information for everything. Yeah. Yeah. So yeah, because in the case of the comparison, right, I only need a function. Don't need state to go with it. Because you never need state when you're doing comparison functions. Like, you never do. The arguments are your state. And then, well, that's it. Just a function pointer. Instead of what the standard library does, which is it has a whole object, right? Which means it has a type ID along with the state for the object, and then it's also got a function, which is stored in its v-table, right? It's also how I'm doing the allocators, actually. Well, it's almost how I'm doing the allocators. I actually do need to hold a state variable also for the allocator. Because obviously the allocator needs to track allocations, right? But yeah, no, I have a type that I've made. It's an unmanaged type, and it's got just 3 pointers. One pointer to state, whatever it is, right? One pointer to an Alex function and one pointer to a free function. And the reason I did that instead of having like an object and virtual functions and all that, oh no, is because, partly because C# straight up doesn't support like virtual functions and all that with unmanaged types. Not really. You can do it, but then you get boxed in and stuff like that, which basically takes you back in the band, right? So that's one of the reasons. But the other one is because I could just make the allocator as like a generic argument, or a generic type argument. You know what I mean? Like a list of integer of this allocator. Okay. But I didn't want to do that because it means that I'd have, 10 different lists. Really. Right? I'd have one for list of integers that are allocated in native memory, and then another for the list of integers that are allocated by a scratch allocator, and so on and so forth. And that would just be really annoying to work with. So, yeah. I don't know what happened. Okay-ish again. I don't know. Whoops, missed it. Aw. Yeah. No. It's so close. Nice. I'm telling you, man, we just need beef to be mainstream. Because beef, man, it's all of this. Yeah. 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 So, yeah. Yeah. Right. I know. I know. Yeah. Yeah, it does feel better than losing. Because my issue with C++ is that it has everything. It is just such a messy language because it has a billion different features. Um, And then my issue with C# is performance issues. Right? The fact that it uses a garbage collector and it's all managed memory and stuff like that. And the weird thing is, they seem to be realizing that because every single update that they have, all of this stuff that I'm doing with unmanaged memory becomes easier. With C#. Yeah, like the last, I don't know, 5 or so versions of C# have all been mostly additions to unmanaged memory and low-level access and reducing allocations and stuff. Like, that's the vectorized instruction sets now. That came out a couple years back. Or I have direct access to malloc and free now too. From C. They introduced a compiler intrinsic for it. And the reason is because they realized that there was a need for it, because C# is sort of moving away from everything being managed memory. Oh. It's in. I missed it too. A little while ago, they added the spans. And C# gotten that added spans a little while ago, right? And memory, and that's designed specifically to be able to do, or to represent just arbitrary memory. So you can use unmanaged memory with the most of the native code base, or most of the managed code base. Sorry. Or like they introduced this whole one about this entire set of APIs for treating spans of chars as strings, right? Because they are. But the difference between a string and a span of chars in C# is that a string is its own object, right? It's been allocated, it's read-only, and it's all that stuff. Which means it's managed, which means it moves around in memory all the time. And it also means it's garbage collected, right? Which could be a problem when you're parsing web pages, because that's all string manipulation, right? And not just that, but like really small string manipulation. So what they did was they did this API for spans, and now you can basically parse an entire web page with a little bit of effort, but not a huge amount, without any allocations at all, without even touching the heap. Or naturally, you know, you have to touch it once to allocate everything initially, but then after that, then it's just one string that you're manipulating parts of. Then. Okay. I know. Yeah, the car's toast over and over again. Disgusting. Oh no. I have no idea. I have no boost. I got it. I missed it. Shit. Did not miss. I think, yeah. You gotta have like superhuman reaction time there and just back up or something. Alright, it's past me. Nice, no boost. Bumped. Can you get that? Oh, yeah, oh well. Yeah, you're not gonna win. 11. Holy. Oh my god. Trust me. Alright. This guy's clear. What? We're good. We're good. Oh, I'm bumped. Oh no. Landed backwards. Yeah. He's got the clear. I'm not gonna skip. Where am I? Did I skip? I don't even know. Nice. Yeah. Okay, well, I'm still beginning again. Oh, that's bad again. Back. Ooh, nice. Mm-hmm. Well, bump me again. I didn't know you did. I'm dead. Nice. There we go. Okay. Nice. He's gonna clear it. I missed. That's an unfortunate, man. Um, yeah, I keep losing my 50s. Nice. Yeah, I cleared it. Bumped. It's not quite in. Shit. Dang it. No, you messed me up. Yeah. Hello. Yeah, I totally forgot I got booted from the party. Yeah. 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 I bet you what I did was I hit because it's competitive, right? So then we end up in different. The guy just saved it. My teammate is an idiot sometimes, apparently. Yeah. Okay. Uh, Yeah. Yeah. Oh yeah. Okay, it's done. Yeah. Hmm. I finished my match. Yeah. You also got to re-invite me to that. Yeah. I have no idea. There we go. I just left it there. So. He could have. He stopped in the net and waited for it to bounce off. He could have just gone for it. He was closer. Well, I mean, all he had to do was just challenge it sooner. Because I was reaching. I couldn't have made it if he actually went for it. He could have, I mean, he could have hit it before. He could have hit it before he even got there. That's what I mean. Well, whatever. I think it's a lie. 'Cause I'm doing fine on my end. Uh. Oof. There we go. Yeah. Center? Well, never mind. He's gonna try and kill me. I have no boost. That's fine. Well, that was ass. Oh shit, I should not have gone for that. Nope. Road to Burst 3, eh? Oh. I got it. Center for them. My mine is not there for some reason. Took my boost. I had nothing still. Honestly, I think if we just keep doing what we're doing, it'll be fine. I think it was just two unfortunate mistakes. That was fun. You almost put it in. Oh, come on. He's there. Ooh. You touch that? Oh. Nice. Yeah, that listens. Here we go. That was. Oh, no, 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 no. You kidding me? Like, I couldn't even see it. Yeah. That bounced too high. Boost. There we go. I got it. There we go. Oh. I took the guy's boost. And then I killed him. Nice. Nice. Yeah. Mhm. See, that's rich coming from today. You know what my sleep was like last night? I was up till 4 in the morning. Sorry, that theory's a bit, broken. Whoa! Okay, I was just disconnected, or maybe I'm back, I don't know. Oh. Oops. Hmm. There we go. Quality, okay. Quality over quantity. I got him. Whoop, I missed it. We'll take it. Whoa, a little bit lag. Huh. What the? Can I take it? Yeah, the ping is getting me now. I think this is gonna be the last game, because the internet's a little bit... yeah. Honestly, I'm getting a little tired actually now that you mention it. Alright, I don't know what's happening. Oh, it's alright. Can't tell if it's my internet or my head, because I'm... yeah, it just hit me like a ton of bricks. I don't know what happened. There you go. You trying to kill me? Bastard. Yeah, let's go for it. Nice. Cleared it. Oh shit, it's in. Yeah, I saw that. There we go. Now we need victory. Nope. Oh, come on! There we go. No, no, no. purpose. I did that one on purpose. I knew the guy was there, so. Oh, I got bumped. Oh, that's in. Nice shot. Mhm. Oh, you got this. Got. I've lost it. Oh. Oh, he took my boost, bastard. No, I'm bumped. Uh-oh. Forfeit, forfeit now, forfeit now. Yup. Yeah. Probably gonna do something else. It's only 5:30. If I sleep now, it's gonna be bad tomorrow, you know?